And welcome back to the Zero Gravity Podcast. Today we have another exciting episode and a very special guest, Robert Fabian, the COO of Vaya Space. I got the wonderful opportunity of touring the rocket factory, and wow, it was amazing. The team there is great, everybody's very ambitious and passionate on what they're working on. We got to learn about the early days of Vaya, and we got a chance to see some of their cool technology that they're working on. Unfortunately, due to ITAR, I can't really show some of the stuff that I was able to see, but I'll go ahead and plug in some publicly available footage that does fall under ITAR regulations and all that fun stuff that you can see. Anyway, enjoy the show. Go ahead and get your iced coffee, whatever it is that you do whenever you watch a podcast. Give us a like, give us a comment, and hope you enjoy. Thanks. Pleasure to have you here. Thank you so much.
It's a pleasure to be here.
So, why don't we start at your early years of getting into business? Tell us a little bit more about yourself. What really got you into this sector, and just walk us through that path that you took.
Sure. I've been a fanatic for space since I was small. About 10 years old, my uncle, Colonel John Fabian, was selected as a shuttle astronaut. So he went up on STS-7 and 51G. And that kind of brought home to me that this was real. This was something I could go do. Mm-hmm. And so I set my sights on going into space and being part of the space industry. At the time, because this was in the 1970s and early 80s, yes, I'm old, the way to do that was through the military, through the DoD. So I went to the U.S. Air Force Academy. I graduated from there with a degree in space operations, which was the beginning of my oddball path, because it's not quite astronautical engineering. We did a lot of detailed control systems work, propulsion work, satellite design work, but it was also policy, doctrine, how are these things used? And so that just resonated with me, that split between the two things. And so I did everything from studying space policy and international space law to working on a student project where we built a sensor for the Strategic Defense Initiative organization that actually was launched into space.
Wow.
I'm not sure if they can see on camera that we have Kinsley, one of the dogs around the office, just wandered in. So
they probably can, which is pretty cool.
Yeah, you guys may see them coming in and out. We are very much a dog-friendly office. There's up to 7 or 8 dogs that tend to roam around our office on any given day, everything from little tiny ones to German Shepherd size. And they're a great addition to the environment and to the team.
So I think that, especially having, like you just mentioned, having dogs here in the office, it's a big change from what it was like in the early years
Very
with
much
space
so.
companies, isn't it? So what was that experience like beforehand with what a lot of people call the old space versus new space?
Well, I did 25 years in the Air Force, so most of my experience was military space. And there were no dogs in military units. You were in uniform, you had strict procedures, regulations, and guidelines on how everything operated. And we've brought some of that here. Our safety programs I would stack up against anything that I worked with when I was in the Air Force.
Wow.
Because that's important. That has to be done to make sure that our people are safe, our products are safe, and our facilities are safe.
That makes sense.
Safety has been a key thrust of Vaya from the beginning.
Well, let's circle back to what you mentioned, which is that you went into the military. Mm-hmm. When you were going through that process, did you ever think about any other industries that you wanted to go to, or was it one of those things that, as when you got hooked on space, it was literally one of those things that just kept you on that path?
No, I knew what I wanted to do. I was a space maniac, like I said, from 10 years old.
Wow.
Every sci-fi book published in that time frame I read. Robert Heinlein was as much an influence on me growing up as my parents were.
Yeah.
And this is what I wanted to do. I wanted to be involved in space, and not just launch and propulsion, but space in general, colonization, utilization, all of it.
I see, yeah.
And so I then followed a path through the military that led me where I was passionate about.
Yeah.
So I started off in space surveillance, tracking satellites.
How was that when back then? Because I know that now there's a lot of new tools. There's AI even now for tracking satellites. But what are like some of the big differences from tracking them?
It was very manual, but it was also a much smaller catalog that we had to track.
I see.
So my initial assignment was with the 8th Space Warning Squadron, which was a PAVE-PAWS phased array missile warning radar. So we had 10-story phased array radar tracking things out into low Earth orbit.
Yeah.
Down to about the size of a basketball.
Size of a basketball. Interesting.
Now, there were other systems that could go down to a golf ball, but we were anything roughly about that big or smaller we could see.
Wow.
It made for some interesting experiences. I've seen firsthand what collisions do.
Really?
I was on shift watching a Russian rocket body, and I believe it was a French defunct communication satellite, tracking both of them as they went, and there were 2 items, and now there are 300 items.
Wow. Just from that collision alone.
Just from that collision.
Now, correct me if I'm wrong. I think that I don't know where I read this, but there's over 100,000 pieces that are of space debris that are smaller than an inch.
That's an estimate.
Okay.
Nobody actually tracks to that precision at that level.
Yeah.
But there's been a lot of research done by NASA, by the U.S. Air Force, now Space Force, and the international community trying to characterize that debris environment. And it's a serious concern, but it's also something we need to make sure we understand in context.
Yeah.
I saw an actual collision.
That's
rare.
That's insane.
I saw it on a radar scope, so I didn't actually get to see it. But that's very, very rare. Usually when we were worried about conjunctions, it meant 2 satellites were coming within, and pulling a number out of thin air, 50 kilometers of each other.
Okay.
That was a close approach. So space is still very, very big,
and
the satellites are small, but every time we put something else up there, it's that much more likely that something's going to cross. And
I've seen a lot of headlines recently where there's there was a recent one with I believe it was a crew up there from NASA that had to get into their spacesuits, given that there was some space debris that was coming very close to the Dragon capsule, I believe.
Yeah.
So it is a growing concern. I had a couple of conversations with a couple of people in the sector, and there are concerns for that aspect of things. So I think it's a great opportunity for startups. So I'm excited to see some of those solutions starting to come up, and some of those concept designs for vehicles that might be able to collect them. But so you were able to track satellites. At what point did you make that pivot to going into the private startup?
Not till after I retired from the Air Force, although it really started before I retired. So fast forward all the way to the end, I've done space surveillance, I've done maintenance and leading the maintenance teams on Minuteman and Peacekeeper ICBMs, so hands-on with solid rocket motors and the hypergolic liquid final stages that we use for those. Nasty stuff, by the way.
Yeah.
I was in Minot Air Force Base as a commander of the 91st Maintenance Ops Squadron when we, as a wing, rolled a transport that had a Minuteman missile in it.
Wow.
No warheads, there's no nuclear involved, but this is still huge amounts of solid rocket motor lying in a ditch in the middle of North Dakota.
Interesting.
It took us 3 months to safely get it out of the ditch and back in where the Air Force could analyze it and assess it, simply because of the volatile nature of solid rocket motors.
What were some of those procedures?
We didn't actually do it. We oversaw it as the maintainers. They brought in specialists from the program office to do this. But it was a series of cutting away the truck body itself to get at the missile without producing any sparks or any other way of igniting the motors, and then assessing the condition of the motor. Was it broken? Was it cracked? Where was it cracked? And then very carefully and safely chopping it into chunks that could be craned out and removed.
Interesting. Sounds like a very complex procedure.
It was my life for 3 months.
Wow.
I was 12-hour shifts in command post as part of watching over this process. Intense for me, but I'm in a command post. The guys out there actually doing it, they were out there for 3 months in that environment.
I don't think a lot of people understand just how delicate some of these things are when it comes to getting hands-on, especially like you talked about hypergolics. It's, like you said, they're very nasty materials, and they can get very messy very quickly. Yeah.
My team's trained in how to respond to those hypergols if there was an accident. Thankfully, I've never been involved in one. But we had to go in with full environmental suits. So a complete isolation from the environment, umbilical hose running back, providing air, power, comm.
Wow, okay.
Because if you got exposed to these things, they were lethal.
Yeah.
monomethyl hydrazine, for example. My maintenance troops used to laughingly refer to it as monomethyl kilosol.
Kilosol?
Yeah.
Interesting.
And it's handleable if you know the rules, but you have to be very careful with it. So going back to what led me to the private sector, my final assignment, I was the Deputy Director of Plans and Programs at Hill Air Force Base, which is the depot for the Minuteman ICBM.
I see.
And also the nuclear integration team lead. So I was sort of the general's lead nuclear missile guy. I had several engineers who their job was to go find technologies that were of interest to the depot. And one of them came running into my office, Colonel Fabian, you got to see this. They've got a rocket that can't blow up.
Okay.
I won't repeat what I said.
Sure. I mean, this podcast will blur whatever you want.
The immediate reaction was, that's not possible. If
Right.
it can't blow up, it can't propel anything.
Yes.
And he said, no, look at this. Look at their design, look at the physics. They're doing some small-scale testing up at Utah State University. So I looked at it and said, I think they're right. On the surface, this looks like it would fail safe. And
Interesting,
it was a hybrid. I'd never really been exposed to hybrid rocket engines other than in theory before.
Yeah.
So I went up to go see those very, very small-scale initial demos and thought, this is really cool. I pointed it to some people within Headquarters Space Command and said, you guys should talk, and considered my job done.
Yeah.
So you fast forward about another 2 years. I had been deployed in Iraq for a year and come back and was in the process of retiring when who's sitting 3 rows behind me on the plane that I'm on? The president and founder of that company that I had met.
Oh, wow. Interesting.
So we got to talking. I told him I was retiring, and he invited me to be on his board of advisors.
Mm-hmm.
And that quickly turned into vice president for propulsion, not for pay. We were a startup. We had no money.
Right.
I was doing it evenings and weekends while I went and found a job with BAE Systems.
Interesting. What was that like, especially when you mentioned, as a startup you have no pay.
Yeah.
And I'm assuming that at the time, the private sector was still kind of questionable whether it was going to be successful or not. How did you handle that?
I did it as a labor of love. I was passionate about what the engine could do.
Yeah.
I was fascinated by the potential, and so I spent most of my time reviewing designs on a couple of the other engineers who were working essentially for stock.
I see.
At that time, with day jobs and proposals, and we put together a proposal to DARPA to demonstrate a design and build and test of a 5,000-pound thrust variant of our engines.
Wow.
When DARPA came back with the grant, we could actually start paying people. We could actually start bending metal, and that's when I walked into my boss's office at BAE and said, Lyman, he and I were old friends from on active duty. I told you when you hired me, if this rocket company ever took off, I was going to leave. They're funded, at least to start, so this is my 2 weeks' notice.
Oh, wow. Yeah.
And Lyman Faith, my boss at the time, a great guy, said, understand, Rob, this is your passion, go for it.
Interesting. Was there any, I don't want to say any doubts, but was there any people that you knew personally along the way that leading up to that point were questioning a lot whether it was going to be successful or not?
Oh, absolutely.
I guess what you would call now doubters, or I wouldn't say haters, but doubters.
Not really haters, but doubters. Mostly they question the funding sources, not necessarily the technology.
Interesting. I see. I think what I see a lot with startups right now is that they'll run a lot towards funding without necessarily working on the technology. So I don't know if you've noticed that too in some companies.
We did something very different here, and we did it deliberately because we'd seen that.
Interesting.
So we like to say that we're proceeding at the speed of funding.
I see.
So rather than, like, is as you said, the common approach, going out with a good idea on PowerPoint, getting a bunch of money and go seeing if it worked, we figured out what's the minimum amount of money we need to raise to prove out points along in the technology.
Yeah.
Raise that, go prove it, use that proof to go raise more, and cycle and slowly build.
Yeah.
And it's got its goods and bads. It's slower. We've been doing this actively bending metal since 2007, so it's taken us 7 years to get to this point.
Yeah.
On the other hand, I've never had to lay large numbers of people off. We've never had to shut down the company. We've never, we've kept the company alive through lean times and investment times by being precise and deliberate about our spending.
How do you go about making those type of decisions for a company like this? Because in my mind, as an outsider, so I'm also a startup founder. I'm in the solar sector, so it's okay. I gotta understand the industry so I can effectively lead the company. But if it's like, okay, it's a solar company, but when we're talking about a launch company, it's totally different. It's a completely different animal. It's very, very niche specific, and a lot of people don't even want to challenge that just because of how hard it is. So keeping that in mind, when you decided to run the company and come in and pretty much make those decisions, how did you equip yourself, aside from the experience that you had in the military? Was there any form of model that you used to make the decisions, or to say, okay, well, this is where the industry is, 7 years ago when it was still very new? Kind of walk us through that decision-making process.
It was kind of a mixture of that.
Okay.
So we looked at where the industry was and where we thought we were improvements on it. And that was we used that as initial claims, but being very grounded in truth. So we did not want to go out there and make grandiose claims, especially since we were claiming that we had made hybrid rocket engines work on a commercial level. And hybrid rockets have been around for 100 years. They're great for research or for toys or for education, but they're not reliable. They're not consistent. A lot of thrust instabilities, and they're very difficult to ignite. So they've generally never been used in the commercial world. Now that's changing. We're not the only hybrid company out there anymore. As technology has advanced, we've found ways to mitigate those.
Interesting.
But we took the approach that extraordinary claims require extraordinary proof.
I see.
And so we would ratchet up our fundraising based on what we could prove.
That makes perfect sense. So, now let's talk a little bit more about Vaya specifically in itself as a product. For some of the viewers that are looking at this, the mainstream companies are SpaceX, Blue Origin. You have these companies who have been able to establish a name more in the mainstream media. But I've always been really fascinated by the startups and by the companies that don't get as much coverage as they should. Just the technologies that they're working on are great, and I think more people should know about that. So if you could summarize Vaya Space to the viewer out there, what would that be?
Vaya Space is a small launch and propulsion company focused on a breakthrough in hybrid rocket engines. So our Vortex hybrid engines are smooth burning and stable, controllable, throttleable, restartable. We've licked the ignition issues that hybrids have as well with a system that can do multiple restarts.
That's pretty cool. It's hard to do that.
Our test igniter that we built up that we're going to be using on the Dauntless launch vehicle, we've cycled more than 10 relight ignitions from a single igniter assembly.
Wow. Has that been done before, or was there...
Not with a hybrid. So we're using a hybrid to start a hybrid.
So you're a hybrid to start a hybrid?
Yeah, and then lasers to start the startup hybrid.
Oh, snap, okay.
So as long as I have igniter fuel grain left, and I have power to power the lasers, I can start it again over and over and over.
Wow.
It'll shut down and restart based on oxidizer flow and presence of the laser to heat it to ignition.
That's interesting. I didn't know that.
Right now, most restart systems are using generally a hypergol, TTEB, or any one of the other number of chemicals that will ignite as soon as you mix them.
Yeah.
And you typical liquid bipropellant, you flow the two liquids together, you shut them off when you don't need the igniter, and you flow them again when you want to reignite. That means you have to have those hazardous chemicals and all the complicated plumbing in it.
Yeah, interesting. That's actually a really interesting approach. I didn't know that's how it was being done.
We have a patent pending on it right now.
That's pretty cool. So I can't steal it. So let's talk about. So there's a couple missions. There's a mission I saw on the website and that I've been reading a little bit into, and I'm really curious to know more as to what that looks like.
Okay.
And your point of view on it. When do you see that maybe taking off?
Right now, we're projecting our first launch for Q4 of 2026.
Okay, nice.
But as I said before, we're running at the speed of funding.
Yeah.
So I talked about ratcheting it up. each round of fundraisers has been larger than the next. We just started a Series B a few months ago.
Okay. Yeah.
It's going to be around $40 million. That's going to match the total amount of money that the company has raised in its history.
Oh, so, wow. Okay, yeah.
We've done a lot of work on
yeah.
a very small budget for an aerospace company, and it's because of that approach. Yeah. That's not going to get us all the way to launch. We'll have a C or a B tranche 2 in there. So we need about $80 million, $100 million total raise to get us. Now that's still less than $150 million total to get us to the launch pad. So it's incredibly inexpensive from the industry standpoint, but it's also a huge growth in fundraising and company size for us. When I started with the company, there were 7 of us.
Only 7?
Only 7.
And that
we
was
were literally in a garage.
Oh wow! Okay, yeah. Let's talk about that. So only 7 were part of the company.
Right.
That's including yourself.
That's including myself.
And I'm assuming there was lead propulsion, lead structurals, or
we were entirely propulsion at that point.
Wow. Okay. Yeah.
Because what we're doing with our vehicle is innovative but not breakthrough on a lot of the stuff.
Yeah.
And carbon fiber structures have been done before. Aeroshells, stage separation systems. People have done those. Our hybrid motor is our secret sauce. Our early phase of the company was entirely focused on proving out our hybrid motor.
That is insane. 7 people in a garage. Where was this garage?
It's just a few miles over that way.
Okay.
I say garage. It's a garage building, a 3-bay industrial facility here in the Grissom Industrial Park. We're still there. That's our small engine test center.
That's pretty cool. So 7 people. How fast did the company grow? Was it kind of like steady growth, or did it?
It's gone in spurs. Again, as we hit proof points and raise more money, it's another thing I've been very, very specific on is I don't hire people unless I know I can keep them for the long term.
That makes a lot of sense.
And so our growth has been slow and in spurts. We're at about 53 people right now.
Okay.
I'm anticipating we're going to be somewhere between 85 and 100 by the time we hit the launch pad.
That's super cool. Just thinking about the total number of what the company's been able to raise and what you've been able to achieve, you have to be really, really efficient at managing budgets. So I admire you for being able to do it at that number.
It's very much a team effort. We're all in on the scrappy startup mindset with a rigorous engineering and safety approach behind it.
What is the culture like here at Vaya?
Very collaborative. It's one of the things I've tried very hard to maintain as we grew out of the 7 people into this. And when it's 7 of us, we're all sitting in one room without air conditioning when we first started. It was not fun.
I'm glad we have it today.
Yes.
It's pretty hot out there.
Yeah. And so as ideas came up, we literally would just turn over and talk to the guy next to you or across the room and bounce ideas. I wanted to keep that approach here. So as you saw when you came in, it's an open office concept where there's a free flow of discussion and ideas between, not just inside a technical specialty, but between technical specialties.
Okay, yeah.
So we've tried to build and maintain a culture that a good idea is a good idea. It doesn't matter where it came from, whether it's a technician on the floor or the propulsion engineer or somebody over in the guidance, navigation, and control section asking a question of the propulsion guys, hey, could you do it this way?
I see.
Particularly when we run into big problems, we'll pull the whole team in to discuss it real quickly so everybody knows what it is. And then as people have ideas, we'll bounce them back and forth.
Is there a example that you could give us as to maybe a problem that you were trying to solve and then the idea came out of nowhere, or it was...
Oh, I've got a great one for you, and it's very scrappy startup. About a year and a half ago, we went out to do a flight test demonstration. That was our final proof point that we had the engine down. That the engine, as designed here, performed on the horizontal test stand the same way it performed on a vertical test stand and the same way it performed in flight, that there was correlation between all of them. So we went out to the Mojave in an area under an FAA waiver. So we had to downsize the engine, obviously. Had to stay under, I believe it was 50,000 feet and a set total impulse. And we went out there and we could not get the ignition to go. And
Really?
it wasn't that the igniter system was not working, it was that the throttle valve was freezing up from the liquid oxygen tank above it. We had not properly insulated and separated the valve controls out. We thought we had,
Yeah.
but putting it in practice in the Mojave sun, the temperature differentials were causing problems. And so we were trying to figure out, how can we do this without having to go all the way back to Florida and redesign and rebuild and come back out? And one of our technicians, actually our lead welder, stopped and said, I've got these, and he pulls up the chemical hot hands. I brought them out here because it gets cold in the nighttime, and I figured we were going to be out here at night. Can we just use these and stuff them in the compartment?
Yeah.
And so we polled everybody, and we actually had a bunch of people who had brought them for their own
Really?
comfort.
Okay, yeah.
So we strapped them in there with duct tape and baling wire around that valve to keep it warm enough. It was actually the control circuitry was getting too cold. The valve was, but the controls wouldn't go in the cold. Around that circuit box.
Interesting.
To keep it warm enough to operate.
That's insane.
Flew off the pad, 9 test objectives, 9 achieved.
That's awesome.
First day.
That is awesome.
Because my welder diagnosed the problem with the electronics controlling the launch vehicle or the test vehicle.
That's a great example of being able to show that you can solve these problems on the fly. That's really cool. I hear a lot of stories where things like that happen, and there's always this idea that it has to be perfect and it has to be you have to run multiple tests before you can try something. In some cases,
and there's a lot of truth to that.
Yeah.
And we did a lot of thinking and analyzing and making sure we weren't going to do something that was going to blow up in our faces, figuratively, because we've tried to get our engine to blow up. The worst thing that you can get is if it's firing when it fails, you'll get a release of whatever pressure's in the combustion chamber. Mm-hmm. But then because the fuel's solid and the oxidizer is liquid, the two no longer mix in a combustible state, and so the flame just goes out.
Yeah.
But figuratively, we wanted to make sure we weren't doing damage to the system. And so we had to spend a lot of analysis time afterwards, but still done in a day. And
that's pretty cool.
Off the instincts of our welder.
That's really inspiring, especially for, I guess, this is another thing that I've noticed too, is that a lot of people are trying to break into the sector, potentially joint startups, some established companies and welders, plumbers, you name it. So that is, I feel like that gives a lot of confidence to some of the viewers, because it lets them know that their input is welcomed, and it's not just dismissed because you're not an engineer or you're not a, I guess you could say, a technician that deals with it in and out. So that's pretty cool. I was going to ask, so your engine, I believe that there's also some recycled plastics.
There is. We're using that as a fuel.
So
we're burning high density polyethylene as our primary fuel, actually only fuel in this. I say primarily because we've got some defense projects we're now doing. We just finished up with the Air Force and a cooperative research agreement with the Army.
Nice.
That we're looking at a few other types of thermoplastic. But for Dauntless, for our launch vehicle, it's high density polyethylene. It's the same stuff they make milk jugs and bottle caps out of.
Interesting.
And so we're using 99.8% certified post-industrial waste. So it's coming out of the manufacturing plants, not out of the garbage pits.
Okay.
But it's still waste plastic that would have gone into the waste stream if it wasn't being recycled and used by us.
Is there any way that you could utilize what's being thrown into the trash can and that's going into these?
We're looking at that.
Okay.
Not right now because of purity requirements, but we've got some ideas. There's actually some very interesting work being done in the UK on converting that sort of waste plastic into kerosene.
Okay.
I was on a podcast, I guess about 6 months ago, talking about green fuels. And there was a small UK startup that's doing a liquid bipropellant that had spun off another startup to convert plastic trash into the kerosene that they were then going to be using to fly their rockets.
Interesting.
And chemically, kerosene and high-density polyethylene are very similar. So there's a path there, but it's not a side path we want to go down just yet.
I feel like that would just open up a whole new can of worms, and having to put focus and attention to that.
Exactly.
We've
got enough on our plates getting Dauntless to the launch pad right now.
So let's talk about Dauntless.
Sure. Yeah. Mess around. This is Dauntless.
It's so cool. So let's talk about Dauntless. You know, what inspired the design of the vehicle?
Well, basically physics and the market.
So
the first thing you notice is that the strap-on boosters, those are not strap-ons. Those are the actual main engines for the vehicle.
So they're not okay. So
they are not secondary rocket propulsion or anything else.
Interesting.
Those are our hybrid engines. That center core that you see here,
Yep.
that's purely a liquid oxygen tank, feeding all 6 of those other engines.
Oh wow.
And what that does is it allows us to lower the height of the vehicle, which reduces the structural mass, which reduces the weight, and allows us to put more payload up with it.
Okay.
So we optimized this. This one's targeted at about 500 kilograms to low Earth orbit. Our real target area where we see the killer for the market is at about 1,000 kilograms.
Okay.
And we're already working a Block 2 design that will reach that goal.
When does the Block 2 design come out? Like the conceptual designs or?
Well, the conceptual designs we've already released it in some places. It's
Okay.
still in flux.
Okay. Yeah.
But we want to transition fairly quickly after the Block 1 flies into the Block 2. And so it's designed to be very modular. So the Block 1 and Block 2, that first stage is the same.
Okay.
The changes in the Block 2 are all in the upper stage. So in the Block 1 design, we have 6 of these 22,000-pound thrust engines on the first stage. And you have a single one with a vacuum-optimized nozzle on the second stage.
Okay.
That was done in part to simplify FAA licensing. So we only have one engine design that we have to certify.
Wow. Okay. Now, in terms of reusability, what aspects of the vehicle are reusable?
We prefer to use the term recoverable.
Okay.
We are going to drop the first stage into the water
Okay. Yeah.
on a parachute to slow it down so that it will hopefully survive contact with the water. These engines here are going to just be carbon fiber shells with the fuel all burned out.
Right.
They're not likely to be reusable.
Okay.
But the injectors and the nozzles, which we additively manufacture out of Inconel for the injector and GR Cop for the nozzles, those are probably the single most expensive parts in the engine itself.
Yeah.
Those we're going to pull out and assess whether we can reuse them.
I see. Yeah, I've done a lot of reading on Inconel, and it's pretty expensive.
It is.
It's hard to.
GR Copper is worse.
Really?
In
Okay.
terms of price. It's a special NASA alloy, high strength, high durability copper. So we're using it in our nozzles because we're cooling our nozzles with our liquid oxygen.
Okay.
So
Interesting.
we're flowing the liquid oxygen out of the tank through the nozzles, heating it up to supercritical status as it pulls that out and keeps the nozzle from eating itself, and then running it up to the top and injecting it into the fuel grain.
Wow. This is really interesting. I had no idea that those were attached to the vehicle. I did think that they would separate.
Yeah, well, that's the obvious thought most people have on looking
Yeah.
at this, because when you see that on any other launch vehicle, those are secondary boosters are going to fall away.
Yeah, it's an immediate. I guess it's just become the standard in the industry where it's, you have side engines and don't go out.
This is in part because the way our engines are designed. With a standard liquid bipropellant, they tend to be fairly short, and then you have a lot of tankage. But our fuel grains are long and cylindrical, so we would have to have this tank on top of those and then have the second stage. So we would be a significantly larger vehicle if we were doing the traditional model. And early designs on Dauntless were in that traditional stacked approach.
Okay,
and as we ran trade analyses and design work on it, we realized, hey, wait a minute, we can do this, and it saves us all this mass. It puts the center of gravity actually in a slightly better position for us.
Okay. Yeah.
So it just made the vehicle a much more effective launch vehicle for us.
That's really impressive. That's really cool. So when this mission does happen, what are some things that you're looking to learn and that you hope that you do get to? What are some milestones that you hope to achieve?
Well, we've got a whole series of testing milestones leading up into that. Everything from a variety of single engine tests that we're gearing up to do now. If you go another 3 or 4 miles past the garage, back in the swamp in a more isolated area, there's a test facility that we're building out there for our large engines.
Nice.
It's about 99% complete now. I'm meeting with my test director pretty much on a daily basis, trying not to micromanage him as he finishes it up. So we've got a series of tests. We want to prove the large scale on this works. So we've tested at a variety of different scales, everything from 150 pounds of thrust to 5,000 pounds of thrust. And we've used that to build a physics-based model on how our engine works, which allows us to do most of the design work for any particular size or performance that you need through generative algorithms, and then the engineers take the remaining 20% to finalize it. What that means, though, is that these 22,000-pound thrust engines, we have very high confidence in the predictions on how they're going to behave. We've not fired one yet.
Okay.
And that, I'm very much a trust but verify, especially when you're talking a rocket engine this size. So we've got a series of tests we need to do out there.
That's really interesting.
Then we'll go into stage tests where we will take our transporter launch system, tie down the vehicle, and test all 6 engines running in parallel.
Wow.
And the same for our second stage as a separate item. Our goal is to make sure that by the time we get to the launch pad, everything that can be tested on the ground has been tested.
That makes perfect sense. I think at one point I even emailed the team saying, "Hey, like, if it's possible, I know this is a lot of ask, but can we see an engine test?" They're like, "Well, we're not testing engines right now."
We're largely pushing on that large engine test.
Yeah.
We have been doing a few small-scale defense tests, but it's a different engine. It's not even using the same oxidizers.
I see.
On that, because liquid oxygen is not something you want to have in the field when you're doing military maneuvers.
No, that makes perfect sense. I think that's, what you guys are doing here is it's amazing. The approach that you're taking is definitely different with the vehicle design. So I'm assuming that the aerospace industry in its own, especially with launch, it's very competitive, and I'm sure that it's very how can I put it? Ruthless in a way. What's your experience been with that? Or
it is and it isn't.
Okay.
Everybody's after their share of the pie, but we all see that the pie is big enough for multiples.
Okay.
The demand really is far exceeding the launch capacity.
I see.
And what I've found, particularly on the small startups, is there's a sense of camaraderie as well as competition. So the Space Pioneers event that I met you at, I was up there, Stokes was up there, ABL was up there. I actually meet with the local rep for Stokes and ABL and Phantom Space on a regular basis.
Really? Okay.
We call ourselves the ICBM Row Mafia because we've got launch sites down the used to be ICBM test launch sites at Cape Canaveral. And so we've got a sort of thriving discussion between us over issues of the day. So as the Space Force is making rules and changes out at the Cape, they come to us as much as they come to SpaceX and the others for input, and we'll discuss it among ourselves and where it makes sense, present a block position. Hey, the small launch guys believe this.
I see. Yeah. So it's not you're not excluded from the conversations. It's not like your opinion doesn't matter.
Space Force has done an excellent job of keeping the small guys engaged in this, and in being experimental on some of it. So you may have seen the press release about our launch site, LC-13.
I did. That's a shared pad?
It's a shared pad with us and Phantom Space. We had been talking with Phantom and with Stokes, for that matter, at that point, about proposing to the Space Force a shared pad concept.
Okay,
When Space Force did their review of launch pad assignments, they looked at our propellants, Stokes propellants, Phantom's propellants, and some other things. And so they ended up giving Stokes their own site. They didn't see a whole lot of common ground. I think there was some, but they're right. We and Phantom had much more in common. And so they took us at our word. So you guys were talking about this with us, go do it.
Wow.
And they've been very supportive of us as we've moved forward on that.
And this is going to be the first time that there is a shared pad for private companies, or? Yes
and no.
Okay.
Space Florida runs LC-46.
Okay.
And LC-46 is a shared pad in the sense that you go and you lease it for a launch, and then you go. You don't own it. You don't run it. You're a visitor on it.
I see. Okay.
And it's also shared with the U.S. Navy. They do testing there, so you have to work yourself around the Navy's schedule. This is going to be the first time that the launch service providers themselves are running the shared pad.
Okay.
I meet with Phantom on a weekly basis as we're working through all of this. We're in the environmental assessment stage and initial architectural review of what we want to do to the site stage. right now SpaceX is still landing there. It's still their pad until the end of this year.
Okay.
And there may be a need for them to land a little bit longer. It's one of the nice things about the community here. We're open to working together on this. So SpaceX has also been very cooperative with us, letting us get on the site, take our measurements, discussing what they want to leave behind, what they want to take with them, so that we're all on the same page as we move forward.
Well, that's really good to hear, because I think that especially for viewers or for people who want to get into the space sector and do some form of startup, that's one of the biggest fears is, how competitive is it? Are they even willing to work with you in some things? So I think that's really reassuring.
I've seen it in a few areas. We're also we're one of the founding members of what's called the Space Coast Consortium Apprenticeship Program.
Okay,
so that's at the technician level, doing apprenticeships along with academic training at Eastern Florida State College for mechatronics apprentices. We're setting up an advanced aerospace welding, looking at additive manufacturing, and a few others. But when it started, it was mechatronics.
Yeah.
Blue Origin is in that. We're in that. OneWeb is in that. And we work to administer that program smoothly and easily among ourselves.
What was the reasoning for starting that apprenticeship program? Was it to get more talent in the door, or to inspire more startups? Like, what was one of the...
It was really aimed at the talent pool.
Okay.
And growing the local talent pool here, both inspiring high school and younger students that, hey, this is... You don't necessarily want to be an engineer. That's great. You can still be in the space world this way.
I see. Yeah.
And it's a little broader than that, because it's not just space companies in this consortium. There's I believe a surfboard manufacturer in there. Knights Armaments, who's a major gun manufacturer, is part of this. It's really manufacturing here on the Space Coast writ large.
Nice.
The mechatronics has a definite aerospace tinge to it, but it's not the only part.
I see. What are your opinions on the space in the space sector in terms of new launch companies? Because I feel like I've read and I've also heard opinions on both sides. Some that say, well, right now is the perfect opportunity if you do want to get into launch, and then others that say, well, that wave has passed. There's too many launch companies. What are your thoughts on that?
I've heard that, and I want to differentiate between launch companies that are bending metal and launch companies that are PowerPoint deep. There's a lot of launch companies that are PowerPoint deep out there. A lot. I think if you tried to divvy up the demand among all of them, there's more launch companies than there's demand. No question.
Okay.
But when you look at the ones who are serious, who have raised money, who have actually bent metal, who have actually fired engines, the demand is big enough for all of us.
I think at one point, during the first time that we met, I even brought up the question about point-to-point transportation and that outlook. I'm curious if you're interested in maybe revisiting that and seeing if that's something that
it's something we've discussed in the company in the past, and I could see it potentially down the road. We would have to change our approach on it. When we were looking at it, we were looking at fall back to the very, very early stages of the company. This was not what we'd envisioned. We had an envision for a winged glide back first stage booster, all the science fiction dreams for reusable launch. And I wouldn't say we've entirely given that up,
right?
But we realized that the R&D necessary to get there from here and the costs necessary to get there from here were more than we could ever raise at our level.
I see.
And we went to the expendable, and we're looking at where we can reuse that. My personal opinion, and just Rob Fabian's thoughts, point-to-point transport's not going to be commercially viable until you have a fully reusable vehicle doing it.
I see, yeah.
Because you're going to need too many launches on too regular of a basis, and the price point for an expendable, even an expendable as inexpensive as ours, is still pretty high.
What are your thoughts on the space law and policy? Because that is an area that's still kind of developing. There's a lot of, like, I'll throw out the space junk as an example. You can't go out there and collect any kind of space junk that might not, what if it's another country's space junk? Like, there's rules against that. So what are your thoughts on the policy right now and, like, the law on space?
I think it's evolving, and there's an awful lot of that policy that's based around the do not interfere clauses in the Outer Space Treaty.
I see.
So one of the things I did when I was in the Air Force, I was in the Office of the Secretary of Defense's Space Policy Branch as an analyst. And I drafted a change to the DoD's policy on illuminating satellites with lasers for tracking. So low power, not weaponized. When I first came into that issue, it was thou shalt not. Unless you had a written authorization from the satellite's owner, you would never put even a tenth of a watt of laser energy on somebody else's satellite. And that didn't make sense as we were building up more and more capabilities for high precision tracking with lasers. That was great for tracking our stuff.
Yeah, but not
for anybody else's. And if it's an optical satellite, absolutely, you don't want to do anything to mess with the optics.
Yeah.
If it's a communications satellite, that very low power laser is not going to do any damage. And so it took 2 years to cycle this through. But we finally got it approved that with the commander of U.S. Strategic Command, now U.S. Space Command would be doing this, with their approval or certification that it was safe to do so. So a lot of groundwork to make sure it's safe. We could do that.
Yeah.
And again, because it wasn't interfering. It was causing no damage, no disruption of mission operations. It was just tracking.
Do you think that the pushback came from the lack of I guess you could say open-mindedness and just how new it was at the time?
It was a lack of familiarity. We were tracking with radar. And nobody had any problems with putting large amounts of radar energy on a satellite to track it. Not a problem. But as soon as you transitioned into the optical band, it became an issue.
I see,
and it was more, again, Rob's personal opinion, an emotional response rather than an analytical response.
I see.
I think we're going to see the growth of that in the debris mitigation issue you talked up as well. It's like, yes, it belongs to the other country, but it's causing a hazard, and so we're going to have to come up with a way that allows that to be cleaned up
100%
at some point in time.
Yeah, and I think I heard one of your interviews as well where you mentioned that the demand that we need to get a pretty good amount of satellites up there to be able to start expand on communications and all that fun stuff. And as a startup founder in the solar sector, I can see how a platform like this where you could send items into orbit is very valuable. Because we need to take a look at roofs, we need to see exposure, we need to look at trends. So I do see the value in that, and I'm curious to know what kind of companies you can see in the future spinning off from some of the platforms that will get you into space.
Well, I think it's very much going to be a field of dreams sort of thing, and we're already starting to see that. If you build it, they will come. People will find more and better uses of satellite imagery, satellite communications, the cheaper it becomes. So just Starlink as a first example has spread widely, and we're seeing a lot of other uses that people didn't think of for it. Airplanes, I just read an article recently that several major airlines are transitioning to Starlink to provide live internet access on their planes.
I think United actually announced that they're going to do it completely for free on your flight. So that's
So that, again, 5 years ago, we would have laughed at the idea of internet for free on your planes, and 10 years ago, we would have laughed at the idea of internet on your plane.
Yeah. How do you see the potential for space-based solar power through constellations of satellites becoming a thing?
Potentially. You got to deal with the energy download or downlink issue.
I see.
I actually looked at that a good bit when I was on active duty, more out of curiosity than out of actual duty. But making sure that your beam, because when you're talking significant amounts of power, that's potentially dangerous, is broad enough over an area that you're not impacting people, facilities, or wildlife. But at the same time, how much land are you now taking up with that antenna farm to receive that power? So there's a trade-off that's got to go in there.
I see. Yeah, I'm really interested to see what kind of companies come out from that. And I guess that leads to my second question, which is with Vaya Space, I've seen a couple of faces as I was walking in, and some of them look very young. So it's I'm curious to know what does it take for someone to be able to work here? What kind of qualities do you look for in a person to consider them a potential employee of Vaya?
Well, we're looking for particularly for my engineers, a strong technical background and a passion for what they're doing, whether it's with propulsion systems or structural systems or guidance, navigation, and control. I've got an interesting problem here. Most COOs, if they're dealing with attendance at all, they're worried about making sure that people are actually productively working during the hours they're clocked in. I actually have to go around it in the evening sometimes and tell people to go home.
Really? Okay, that's a good problem.
What we've built here is a group of people who are passionate about what we're doing, and so the old saying that the more you want to get something done, the less you call it work.
Yeah,
very much applies here, and so we look for that passion during the interview process. We look for a certain flexibility of mind so that they can take in new ideas and adapt them. Not just everything, but think critically about those new ideas.
Yeah.
And frankly, in engineers, we look for hands-on. We look for people who are not just calculations and clean sheet design, but who are comfortable going in and turning wrenches on the plumbing. Not that I'm necessarily having them do it, but I want them to understand what the technicians are going to have to do with their design.
So it's more of a this is what it works on, like on paper, go do it, and then they do it, and then it's like, oh, well, this is not what you said it was on paper. It's actually like, okay,
and an understanding of what you're asking people to do. You do a design and say, tighten this nut here to this torque specification, and you don't pay any attention to the fact that the clearance around that nut is a 1/4 inch, and it's 3 inches in, and how do you get in there and do
actually
that?
do that part? That makes a lot of sense.
I saw a lot of that in the military, a lot of streamlining on the Minuteman ICBM, where we were trying to take those things out and fix them, and it had largely been done by the time I was involved. But you could see the disconnect between the design engineers and the technicians in the field, and that's what I'm trying to avoid here, because we've got too small of a team to be wasting our time with designs that are not implementable.
That makes a lot of sense. Now, what about for roles that aren't engineering? I'm sure that there's people out there who do the apprentice program, right? That you mentioned that you're putting students into.
Well, we look for that same sort of mindset in our technicians. We want people who are passionate about what we're doing and who are comfortable with their hands and flexible in their minds, so that they can absorb what's going on. As I said before, we're open to good ideas no matter what the source. So we've had a lot of things come out of the technicians. Hey, couldn't we do it this way?
Yeah.
So we want the people who are thinking, not just following instructions.
That makes a lot of sense.
And then beyond that, we want that sort of openness to ideas of discussion at every level, whether it's purchasing, HR, finance. And so, we're a young company. Most of our people are in their 20s, but it's really more focused on that mindset. So our controller is 10 years older than I am. And I'm not exactly a spring chicken in this company, but he's still got that mindset.
Yeah.
We have one of our engineers is, again, in his 60s. He was a vehicle project engineer, clean room engineer for NASA for his whole life. This space is what he does, and he's right in there along with everybody else. That
is awesome. It's really fascinating to learn about teams that are that way, that they're all working together, passionate about what they're doing. How different is, I guess, we touched on engineering and on techs, but what about sales and marketing when it comes to a launch company? What's that like?
Our sales and marketing department's pretty small, in part because we wanted to get to the point of having a vehicle that's ready to go.
Yeah.
But they're just as energetic and committed as anybody else. Our newest hire in sales and marketing, for example, graduate of Georgetown University, former intern in a congressman's office.
Wow. Yeah.
He could be doing much better paying lobbyist sorts of work in K Street in Washington, D.C. He's here because he interned with us once, fell in love with what we were doing, and he wanted back in.
That's awesome. That's really cool. Well, I'm glad again to hear about the type of talent that that's at Vaya. I'm really excited for his future. One piece of advice that you would give, the younger adults and maybe someone who's thinking about doing a transition from their current profession to something in the space world, what piece of advice would you give them?
Well, I get asked this sort of question. I always start with the same thing. As a piece of advice I got as a second lieutenant, and I suspect my squadron commander at the time had no idea what an impact he was having on me when he said it. But this was a group of young lieutenants, and he told us, if you follow standard career progression, you'll have a standard career. And what I took from that was, go do the things that you're interested in. Go do the things that you're passionate about. And what I've seen over my career, and I've seen in other people's careers as well, both people that I've mentored up and people that I worked with, was when you bring that passion to what you do, you bring excellence along with it. And that in turn opens more doors, and you find yourself going in very interesting directions. I would never have predicted that I was going to be an ICBM maintenance officer.
Wow,
That was not on the cards for me, but I got the opportunity to cross-flow. It's a whole different career field from what I trained for. And I loved it. And so I ended up bouncing back and forth between the two fields my whole Air Force career. Well, they tell you that's a bad career move in the Air Force. That's the way to not get promoted. And I made full bird colonel because I believed in what I did, and it was important to me. So I would tell young folks looking at a career out there, find the things that you're passionate about, and find a way to do that in the work center. The second piece I would say is, don't be afraid to get your hands dirty. I've seen an awful lot of people, particularly in the engineering world, who like to do the clean-cut intellectual design, but don't actually bend metal. The people that I found that are the most innovative are generally the ones who are also tinkerers.
Okay, they're messing around with it. They're trying to see how this works, that works.
Yeah, I don't even want to think about how many different 3D printers my team has at home as opposed to the printers we have here. But many times I've come in and said, where did that particular prototype part come from? Oh yeah, I did it over the weekend at home. Or they'll come in with something that they've modified on their car, or that because they're interested in not just the theory but the application.
That makes a lot of sense.
And so the willingness to put in the hard work that goes with it is key.
And I think one of the you touched on this, which is sometimes when someone gives you a piece of advice, you don't know how much that affects them. One of the things that I took from your speech at that event that took place last year was that you need to have an understanding of what you're doing. Like, you need to really go in depth into what it is that you're trying to work on and all that fun stuff. So as an outsider from the space sector, as a non-technical founder in my startup, I decided to pursue formal education. So I actually ended up going back to school so I could transition into doing aerospace engineering, just again for that passion of wanting to be involved in the space sector. And unfortunately, it is a technical field. I mean, you have to be able to, like you said, get your hands dirty, understand the ins and outs. So I think that's really inspiring, especially to know that you decided to chase your passion and that you were able to now be a part of something as great as what Vaya is. So that's really inspiring and fascinating.
So thank you. Yeah, it's interesting what opportunities life will present you as long as you're going into it with enthusiasm.
Absolutely.
I did not anticipate being in a commercial startup world ever. My personal plan was make it to colonel, maybe make general, but probably not, because that's a very, very tight selection band, and it's somewhat self-serving. But I wanted to make colonel because my dad's a colonel, my uncle's a colonel, my cousin's a colonel.
Wow.
I wanted to make sure I made colonel, but and because I enjoyed what I was doing, and then go work at a government contract and support the military until I was ready to retire. I am so glad I didn't do that.
Well, again, it's one of those things where I was going to ask you before, but it was like, did you ever even see this in your future, being part of a space company, of a launch company?
I did, but not in the small scrappy startup approach. When I retired from the Air Force, I started looking at jobs, and I was looking at some positions with the bigs, with SpaceX, with Aerojet Rocketdyne,
Yeah.
with Lockheed Martin, Northrop. I ended up with BAE Systems, but that's all still very much the old school, more regimented aerospace.
Yeah.
The startup world is so much more fun.
Yeah, I've heard a lot of stories, and
A little riskier,
yeah,
but fun.
And some of the things that we talked about, it's definitely exciting. So for the viewers who maybe want to be a part of Vaya, who want to look into potentially joining the team, if you are hiring,
Sure.
what's one way that they could learn more?
We have it right on our website. There's a careers page, and that has our listings on there. I expect those to go up over the rest of this year.
Cool.
We should be hiring again. For those who are up and coming and college students, we do internships in a sort of a 3 period cycle. So it's fall semester, spring semester, summer. And for the fall and spring, we are open to remote internships
Nice.
for the right candidate. And that's a very good pipeline into the company. A lot of my younger engineers came on as interns first.
Okay,
And
nice.
we got a chance to get to know them, to vet them, to make sure they fit the culture. And then when they graduated, we immediately, even before as they were coming up on graduation, offered them a job.
That's awesome. That's awesome. And about your apprenticeship program, how can they learn more about that?
If you go, I'll get you the website for
Okay,
it, but
yeah.
if you search for Space Coast Consortium Apprenticeship Program online, you'll find all the information on that, including all the member companies and the different apprenticeship programs. I know we're adding a couple. There's a cybersecurity one that we're in the process of adding.
Okay.
There's an additive manufacturing one, which I think is very much a wave of the future, that we're adding as well. That will be both plastics and metal additive manufacturing.
Nice. That's really cool. Well, yeah, I mean, hopefully we can spark some interest, and I guess one last question before we wrap up is,
Sure.
where do you see Vaya in the next 5 years? And
I see us in the next 5 years in two things. One, up and launching on a regular basis, so bringing in actual revenue, so we're no longer dependent on investor money. And then I see our defense business taking off. We didn't really talk about that, but we just wrapped up a feasibility study with the Air Force on hypersonic propulsion.
Nice.
Using our core engine as a feeder for an air-breathing ramjet engine.
Wow. Okay. Yeah.
So that I think is going to end up. It was a phase 1. I think we'll be going to phase 2 around the start of the next year. There certainly is a good bit of interest from the DoD on it.
Yeah.
And I can see that maturing into a very interesting capability for them. At the same time, we've got a cooperative research and development agreement going with the Army on surface-to-surface missiles, and so I can see that taking off, pun intended, as well. So we're in an enviable position because we're really built around the propulsion technology to have two different potentially lucrative business sections going, both launch and the defense. And we're now looking at branching out into in-space propulsion as well. So
nice.
More on that in the future.
Yeah,
But,
that's going to be really, really cool to learn about.
again, all based on our hybrid engine.
That's awesome. Well, I look forward to seeing that launch and some of the test firings and all that fun stuff. So
We'll definitely let you know the next time we're doing it.
that'd be cool. Awesome. Well, I appreciate the time, appreciate the invite, and I hope that everybody watching got a chance to learn more about Vaya, and that this inspires you to maybe join their team. I think it's great, and that you become part of something that's great. So
It's been a pleasure talking with you, and it's good to see you again.
awesome. Thank you so
Thanks.
much.